Hello, everyone. Our project is on a novel uterine suture technique for the treatment of postpartum hemorrhage. Postpartum hemorrhage is defined as the loss of 500 milliliters or more of blood from the uterus after childbirth. Postpartum hemorrhage most often occurs due to the inability of the uterus to contract after birth. It is the leading cause of maternal deaths worldwide and complicates 1 to 10% of all deliveries. More than 14 million women experience postpartum hemorrhage each year.
Existing treatments involve applying compression sutures to the uterus to stop bleeding, but these techniques are time-consuming and prone to comorbidities such as blood becoming trapped in the uterine cavity or the suture strands drifting and failing to apply compression. The B-Lynch technique is currently the most widely used, so our technique is compared to it in testing.
Our proposed novel compression technique, as seen in the diagram on the left, will reduce operation time due to its pre-tied nature. It's also minimally invasive, not piercing the uterine wall, which will limit complications. A graft, the white box on top of the uterus, will allow for evenly applied compression. Additionally, all the materials used are biocompatible and absorbable in the uterine environment.
Our lab has incorporated different testing methods to validate our designs. We first conducted material testing on our sutures, where we found the suture retained no mechanical properties and degraded within the length of the uterine period. Ex vivo testing on a sheep uterine were also conducted, where overall compression was observed. The design packagings have also been developed over the past year. We also quantify our compressions to compare to existing techniques using two different types of designs, one with a large pressure sensors and the other with individual sheets. However, both of them generated high percentage of errors. Thus, we have preserved to make our own commercial sensor with our own circuit board.
We are currently in the process of collecting our pressure data for our ex vivo tests, comparing our technique to existing solutions on the market. For these tests, we are hoping to assess if our prototype has more uniform compression and adequate force compared to existing techniques to ensure it is properly adjusting postpartum hemorrhage. For these tests, we have 6 sensors placed on different parts of the uterus and a PCB board in order to collect the signal from all the sensors and send it to our computer. Existing PCB boards cost over $1,000, which is why we designed our own for under $20. Once the data is onto our computer, we have a MATLAB graphical user interface, which creates a calibration curve for our sensors and then collects the data for all 6 sensors at once.
The next steps of our project include physician testing at UCI Medical Center to gather feedback from doctors on the suture techniques, ease of use, effectiveness, and challenges encountered during implementation. Their insight will guide future improvements. Next, we will finalize the packaging design to ensure easy suture and graft removal for fast application in the operating room when PPH occurs. Lastly, we will develop a manufacturing protocol for large-scale production of the suture, self-fibrin graft, and packaging to ensure consistency, quality, and scalability. We appreciate the opportunity UROP has given us, and thank you for your time.